Forces that astronauts experience are called g-forces, or g-force. It's another way of measuring force acting on people or on astronauts. Rather than just saying newtons, g-force sort of gives us an idea of the force acting on a particular astronaut. It's in multiples of the weight of a particular astronaut. So when we're standing on a planet, we experience 9.8 meters per second acceleration if we're falling, but if we're actually standing, that's what's affecting the world around us. We have a weight force, and it has a force, a reaction force, an opposite force. Every force has an equal and opposite reaction. We're standing still, we have 1 G acting on us. If we're moving up at 9.8 meters per second squared, we're now experiencing 2 Gs of force. In other words, this astronaut would be feeling a weight force of twice his original weight. We use this multiples of original weight to describe what astronauts feel during flights, so that we know g-force levels can be dangerous. If they go over a certain amount of g's, the acceleration of the rocket upwards means the astronauts feel greater and greater weight force down on their bodies when they're sitting or seated. So g-force is a useful tool to allow us to determine or describe the forces acting on an astronaut during accelerations. We can work out g-force using the equation g force equals the rocket's acceleration plus 9.8 divided by 9.8, or acceleration plus g divided by g. And that gives us our g-force. The acceleration of the rocket, that can be worked out, and we'll see that in later quick lessons. A 100-kilogram astronaut and a 150-kilogram astronaut will both experience different weight force, but they will experience the same g-force. So g-force doesn't vary for them because they're both being, you can see in the equation here, the acceleration is the only thing that, and the acceleration due to gravity is the only thing that determines the g-force. The actual mass of the astronaut does not determine the g-force.